you on Planetterrian Daily, episode 77 for June 3rd, 2026. Some interesting findings to cover today. Engineered hookworms can now produce and deliver therapeutics inside a living host. Researchers at Washington University School of Medicine in St. Louis engineered hookworms to secrete therapeutic molecules while living inside the host's gut. The parasites already survive for years by releasing molecules that allow coexistence with human hosts. The team redirected this secretion system so the worms manufacture and release a chosen drug. This approach exploits the worm's long-term persistence rather than relying on repeated dosing. Next steps include testing safety and dosing control in animal models. Now, shifting to a very different area of research. Conversion of wetlands since 1985 has added more than $10 billion to U.S. residential flood insurance claims. Riverine flooding accounts for the measured increase in claims. The analysis matched historical wetland maps with insurance records at fine spatial scales. Wetlands reduce peak flows by storing and slowing water during storms. Future work will examine how restoration projects alter these cost trajectories. Most people assume wetlands are low-value areas that can be drained or filled with little consequence. In reality, they actively store floodwater and reduce peak river flows during storms. Right now, as heavy rain falls on developed landscapes, the absence of those natural sponges is increasing insurance payouts and property damage. Wetland loss since 1985 has already added more than $10 billion to U.S. residential flood claims. The next time local planning discussions turn to unused land near rivers or coasts, the measurable cost of removing those buffers is worth tracking. On a different note, viable cold-adapted yeasts and a complex profile of gut and skin microbes were recovered from Otzi the Iceman's tissues. URAC research scientists reconstructed the microbial profile associated with Europe's oldest natural mummy. The analysis captured gut flora, skin microbes, and cold-adapted yeasts preserved with the body. Some yeasts remained viable when cultured in the lab. Comparisons with modern samples highlight shifts in microbial diversity over millennia. Additional genomic sequencing will trace lineage continuity with modern strains. From long-term biological records preserved in ice, we move to new imaging tools that resolve molecular structures at fine scales today. A contact-free terahertz method now maps mirror image molecular handedness at 100 micrometer resolution across material samples. The new terahertz technique distinguishes mirror image molecular structures without physical contact. Chiral molecules show different behaviors despite identical composition, a property central to drug design and biology. The method achieves spatial maps at 100 micrometer resolution across material samples. It reveals handedness patterns that conventional imaging misses at this scale. Researchers aim to extend the approach to dynamic samples and thicker specimens. High-resolution molecular mapping in materials leads us to high-resolution mapping of molecular barriers inside tumors. Spatial proteomics showed that stromal components consistently limit therapeutic antibody access to solid tumor regions across multiple human cancer types. Researchers image interactions between therapeutic antibodies and the tumor microenvironment using spatial proteomics. Stromal components consistently limited antibody penetration into solid tumor regions. The barriers appear conserved across multiple human tumor types examined. Mapping these physical and molecular obstacles identifies where delivery fails. The technique combines high-plex protein detection with spatial coordinates. Inside tumors, delivery is physically constrained. Inside bacteria, a single tool can now control entire groups of genes. The SONAR platform uses one engineered Cas13 protein whose Cre-rRNA sequence can be switched to degrade, repress, or activate multiple genes in a bacterial operon. The SONAR system uses one engineered Cas13 protein to regulate multiple genes in an operon. Simple changes to the Cre-rRNA sequence switch the effector between transcript degradation, translation inhibition, or activation. The approach works in living bacteria without requiring multiple distinct proteins. It provides programmable, RNA-level control at the operon scale. Tests confirmed orthogonality across different targets. Programmable control inside microbes brings us to questions of how well current AI tools control strain selection for flu vaccines. Two linked analyses found no consistent superiority of AI predictions over standard antigenic cartography and ferret models across seasons. Two linked papers in Nature Medicine examined claims that artificial intelligence outperforms standard methods for choosing influenza vaccine strains. Current evidence does not show consistent superiority across multiple seasons or metrics. The analyses compared AI predictions against historical strain selection outcomes. Authors note that larger, prospective datasets are still needed. Standard antigenic cartography and ferret models remain the regulatory baseline. From vaccine strain decisions that affect millions, we shift to direct observations of care quality during childbirth. In Nepal, Senegal, and Zambia, high facility birth coverage did not translate into recommended clinical practices for monitoring, infection prevention, and newborn care. A Nature Medicine study assessed care provided by skilled health personnel in Nepal, Senegal, and Zambia. High coverage of facility births did not translate into recommended clinical practices. Direct observations revealed gaps in monitoring, infection prevention, and immediate newborn care. The findings come from standardized assessments across multiple facilities in each country. Quality shortfalls persist even where access has expanded rapidly. Human health systems still show quality shortfalls. We close with how entire food systems face simultaneous pressures. Climate extremes, diet-related disease, biodiversity loss, and greenhouse gas emissions are all linked to current production and consumption patterns in Europe. A review outlines how climate-driven droughts and floods compound existing stresses on European agriculture. Diet-related diseases, biodiversity loss, and greenhouse gas emissions all trace partly to current production and consumption patterns. The system must deliver affordable food while meeting climate and nature targets. Integrated approaches that address production, diet, and land use together show the greatest potential. Modeling efforts will quantify trade-offs across these goals. Keep an eye on follow-up safety tests for the engineered hookworm platform in animal models. That's Planetterrian Daily for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for listening, and I'll see you tomorrow. And before you go, this show is part of the NERA Network, a family of daily podcasts covering tech, science, markets, and more. If you enjoyed today's episode, give Models and Agents for Beginners a listen. Artificial Intelligence Explained Simply, for beginners and curious teens. You can explore the whole lineup at neuranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.